Have you ever pondered about the immense power that nuclear energy holds or the catastrophic impact of a hydrogen bomb? A question that may seem daunting at first, but one that we're about to explore. Nuclear energy, the energy harnessed from atoms, is an extraordinary force. It's a force so potent, it powers our cities, drives our industries, and has the potential to shape our future. At the heart of this force lies the atom, a tiny entity that carries within it an energy so vast it's almost impossible to fathom. This is the world of nuclear science, a world where we've learned to harness the energy of the atom, to tap into its immense power and potential. But what happens when this power is used not for creation, but for destruction? As we delve deeper, we'll discover the destructive potential of this energy when utilized as a weapon, the hydrogen bomb. Step back in time to the height of the Cold War, where the genesis of the hydrogen bomb took place. The early 1940s and 50s were a period of intense scientific and technological rivalry between two world powers, the United States and the Soviet Union. This was the arms race, a relentless pursuit of supremacy, where each side sought to outdo the other in weaponry. Key figures emerged during this time, shaping the course of history. In the United States, physicists Edward Teller and Stanislaw Ulam were instrumental in the development of the hydrogen bomb, their work fueled by a desire to maintain a balance of power. Meanwhile, in the Soviet Union, Andrei Sakharov was leading their own efforts, driven by the same goal. This was an era where the power of atom was being harnessed not just for energy, but for warfare. The birth of the hydrogen bomb was a testament to human ingenuity and a chilling reminder of its potential for destruction. To comprehend the true power of a hydrogen bomb, one must understand the elemental processes of nuclear fission and fusion. In the heart of a hydrogen bomb, we find two very distinct yet interconnected nuclear processes at play: fission and fusion. Nuclear fission is the process in which a heavy nucleus, such as uranium or plutonium, splits into two or more smaller nuclei, along with some byproducts. This release of extra particles sets off a chain reaction, leading to the release of a vast amount of energy. Now let's delve into nuclear fusion. It's the process that powers our very own sun. In fusion, light atomic nuclei, like hydrogen, merge under extreme temperatures and pressures to form a heavier nucleus, such as helium. This process too releases energy, but on a much larger scale than fission. The trick to a hydrogen bomb or a thermonuclear bomb is that it cleverly combines these two processes. The bomb is initiated with a fission reaction. The energy from this fission bomb is then used to compress and heat a mixture of isotopes of hydrogen, deuterium, and tritium. The high temperature and pressure cause these hydrogen isotopes to fuse into helium, unleashing a gargantuan amount of energy in the form of an explosion. The fusion reaction releases a colossal amount of energy per unit mass, far more than what a fission reaction can achieve. This is why a hydrogen bomb, which uses both fission and fusion processes, is immensely more powerful than an atomic bomb, which relies solely on fission. It's worth noting that the fusion process in a hydrogen bomb is triggered by a fission bomb. The fission bomb acts as a spark plug, igniting the fusion reaction and providing the necessary conditions for it to continue. So there you have it. The science behind a hydrogen bomb is a blend of two of the most powerful processes in the universe: nuclear fission and fusion. It's a stark reminder of the immense power that can be unleashed when we meddle with the fundamental forces of nature. This process, while complex and intricate, results in a devastatingly powerful explosion. The concept of a hydrogen bomb became a reality with the Teller-Ulam design. Named after its creators Edward Teller and Stanislaw Ulam, this design was a groundbreaking advancement in nuclear technology. The Teller-Ulam design is essentially a two-stage nuclear weapon. The first stage, powered by nuclear fission, acts as a trigger for the second stage, which is driven by nuclear fusion. The beauty of this design lies in its ingenuity. The initial fission bomb creates a powerful blast that compresses and heats the fusion fuel in the second stage, triggering a fusion reaction. This process significantly magnifies the energy yield, making the hydrogen bomb far more powerful than its atomic counterpart. In fact, the Teller-Ulam design made it possible to build bombs with virtually no limit to their destructive power. This design revolutionized nuclear weaponry, leading to the creation of the most powerful bomb ever made. The power of a hydrogen bomb was first witnessed by the world in the Tsar Bomba test. It was October 30th, 1961, when the Soviet Union detonated the Tsar Bomba, the most powerful nuclear weapon ever tested. The bomb was so large it had to be transported by plane and dropped over the remote Novaya Zemlya archipelago in the Arctic Ocean. The explosion was colossal, and the blast's yield was estimated to be around 50 megatons of TNT. To give some perspective, that's over 3,000 times the force of the bomb dropped on Hiroshima during World War II. The mushroom cloud reached heights of about 42 miles, nearly 7 times the height of Mount Everest. The shockwaves circled the Earth not once, not twice, but 3 times. The impact on the surrounding area was catastrophic. Buildings were flattened, forests were obliterated, and the landscape was forever changed. The Tsar Bomba test was a stark demonstration of the destructive power of nuclear energy. While the power of a hydrogen bomb is awe-inspiring, it's essential to reflect on the consequences. The detonation of such a device is not just an explosion. It's an event with long-lasting effects, casting a shadow that extends far beyond the initial blast. The environmental cost is substantial. The radioactive fallout contaminates the air, water, and soil, disrupting ecosystems and contributing to climate change. Then there's the human cost. The immediate loss of life is staggering, but the subsequent suffering from radiation sickness, genetic mutations, and psychological trauma can persist for generations. The power of nuclear energy, while incredible, must be handled with great care and responsibility. We've journeyed through the birth, development, and testing of the hydrogen bomb. From nuclear fission and fusion to the Tsar Bomba, we've explored the might of this formidable technology. Remember, knowledge is power, so don't forget to subscribe to our channel and leave a comment below with your thoughts. Until next time, stay curious and keep exploring.